It's Don here from the board. Thanks for coming along and checking out this video. So this is the next part in my mini wood turning journey, wood turning adventures. Just need to adjust my speaker there because it's rumbling. Not quite sure what's happening in my microphone chain here, but that's okay. Right, so in the last couple of parts, I tried to turn myself an encoder knob from some scrap citrus timber from my parents' place, and the last time I attempted it, I had some timber and it had a bit of worm activity in it, and it was catching on the chisels and causing all sorts of grief. So I ended up getting another piece and trying to do a better job sharpening it, increasing the speed of it, and I actually got some pretty good results. Now, of course, if you haven't seen those previous parts, you can always check out the playlist. There might be a card somewhere that's going to pop up that you can have a look at. But I wanted to show the progress of this and just talk over some of the challenges going forwards. I don't have the lathe pulled out and here on the table, but I guess I'll just describe it anyway. So I was quite happy with the progress in what I managed to do, and with my experience in turning all of the other pieces, I got quite a uniform piece of wood, a cylindrical piece of wood that I was happy with dimensionally speaking. And then I set it up in my 3-jaw chuck to drill or bore a hole on the underside for it to go on top of the encoder knob. And so this is what that looked like when I managed to do it. It worked. What I did was I put a drill bit into the tailstock, started off with a small diameter and just worked my way up so that I could actually clear it out. What I probably would need, or what I would want to get, would be a, I believe it's called a Forstner bit, and it's a far better tool than just a straight up drill bit. It's designed for these kind of applications in boring out holes in timber far more efficiently than a drill bit is. Drill bits, aren't really designed for this kind of thing. Anyway, after I did that, I thought, that was going to work really well, and then I put it onto my rotary pad there, as you can see, and it fit. So I was really happy with it because you can still see the end here, which hadn't been taken off yet, simply because I was just checking that the hole size was suitable in case I needed to put it back on the chuck and do more work on it. So I then finished it off. I trimmed this bit off with a saw, and then I smoothed it down and so on and so forth. So what that's left me with is this. Now this has already been somewhat finished by hand with a bit of natural beeswax, and what it's done is it's kind of given it a little bit of a different tone, because from the picture you'll see that the picture, it's a much whiter wood about it, and so by applying the beeswax to it, it's kind of like a stain as a finish, and it's just given it a bit more depth to it and showing off a little bit more of the grain features there. That was actually really hard work because I hadn't melted or softened it, and I was just putting it on a bit of rag and working it in. So there's the end of it that's been tapped from the drill bit. It makes an absolutely horrible noise, and I did accidentally bump it when I was just sort of trying to smooth it, and I took a gouge out of it, so that wasn't cool, but it's still okay. And then that was just the top. I sort of finished it off there, a little bit rough, but it's still okay for my level of skill, right? For my level of experience right now. But then what I discovered was when I went to put it back on, it's not that it doesn't fit. It does fit. Okay, so it goes on. And I could push this further down, but look what just happened. It's now pressing on the next keycap. Why? Well, it's because it's off center. See, that's okay. It's returning. That's not okay. It's not returning. So what had actually inadvertently happened when I was actually boring the hole into this was that it went off center. And I didn't realize until I'd put on keycaps on how bad that was. So if we look at it from the top-down view, right, with these keycaps, it actually manages to contact the other keycaps as it turns around, right? So that's hitting the one on the left, and now it's hitting the one above it. So that wasn't cool. And I was trying to figure out why that was the case. Was it the tailstock and the drill bit, because I'd made my own 3D printed adapter for the tailstock to fit the drill bit? Turns out that was actually part of the reason, but it's also because the actual motor on the lathe has a lot of slop in it. When you fit the 3-jaw chuck on it and it spins, it has a lot of wobble. It wobbles around a lot. And once the drill bit started going into it, it starts it and catches it at a certain point, and then it just ends up wobbling around that axis, and it just causes this. It's not just offset, it's actually angled. So that was the unfortunate result of that. I don't really have a solution for that. The Forstner bit is not necessarily going to fix that. A shorter knob might actually be less susceptible to that. The only real solution would be to actually turn it much smaller, so that even taking that potential issue into account will give it the clearance so that when you rotate it, it will not contact the keycaps next to it. And that might be what I do in the end, right? If I want to keep making more of these or playing around with it. And that's okay. But it's a learning experience, and it just goes to show in terms of what you pay for the equipment, the quality of it, the concept of it. You know, it's just a DC motor, right? Relatively small DC motor. You're kind of going to have some of those issues. And if you were working on a bigger machine, it might not have as much of that wobble, or it might, but it would be less of an issue because you wouldn't be machining on a big machine stuff of this size, whereas you'd probably be using a much more precise, smaller, better quality workshop lathe that would be in the order of several hundreds of dollars to get the precision of milling something like this. And that's not unusual. You see them in the $3, $4, $6, even $1,000 for mini lathes. I mean, most of those are designed for metal work as opposed to timber, but obviously you can still put timber on them, right? They're going to have a lot more power, but they've got more precision because they're designed for manufacturing precision parts. Whereas this is just a tool for a hobby more than anything else. Nothing too serious. At the end of the day, I think it's a fun thing to play with. So I will still, use it and try and get a bit more out of it and make some different things. It just really just comes down to what timber supplies I have available and the time to do so, with the kids being kids, taking up energy and mental space and health concerns, because with one of them being a bit younger, if you're not watching over them, they'll pick up and shove something in their mouth in no time flat, which is not really advisable if it's not something edible that they should be putting in their mouth, such as encoder knobs. In any case, look, this part I got to here. It works, it turns, it looks nice, it's natural, it just has some clearance problems. So maybe if I do another part, we'll get to a better quality, slightly smaller, that will have less of these issues. Well, that's it. That's a wrap. I hope you've enjoyed the journey so far and checking out what I've been doing with the mini lathe and whatnot. And yeah, if you like the channel, hit that like button. If you want to see more of this kind of stuff and other wacky mechanical keyboard related content, hit that subscribe button and bell notification button. Give me some feedback below on stuff I could maybe do with the mini lathe, or any hints and tips that might help me cut down and reduce the amount of slack, the wobble, the slop, whatever you want to call it, whatever the correct technical term is, in that DC motor. That might help me get better results. So thank you very much for checking out this video, and of course, as usual, until next time, happy clacking.